Hello students, welcome back. Our last set of notes for this unit is called Predicting Products of Combustion and Double Replacement Reactions. So we have covered synthesis, decomposition, single replacement, and now we're finishing with double replacement. So we're going to start with combustion because it's probably the easier of the two. Combustion, how do we know we have a combustion reaction? Well, we have a hydrocarbon, which we've represented before with a generic formula of CXHY, and it will always be plus O2. If you have these two items as reactants, you know you have a combustion reaction. So how do I predict the products of a combustion reaction? Very simply, our products of a combustion reaction that's a hydrocarbon is CO2 and H2O. These are your two products every time you have a combustion reaction. So very simply, all you have to do is put CO2 and H2O. So let's take a look at an example here. We have methane, which is CH4, is burned in air. When we have something burning in air, that always means we add O2 to it. So we see we have a hydrocarbon, and we also have plus oxygen, which tells us our products are going to be carbon dioxide and water. So very easy to predict the products here. Our last step, and probably the tougher step in this one, is to go ahead and balance. So one carbon, 4 H's, 2 H's, so I'll put a 2 out front. That gives me 4 H's. That gives me 4 O's on the product side. What times 2 gives me 4, 2, and now we have a balanced reaction. We can add in the ones if we want, or we could just leave it blank. So that is a combustion reaction. Now switching gears just a little bit, a double replacement reaction. So how do we know we have a double replacement reaction? Well, we have a compound plus a compound on the reactant side, and this is the only one that does that. How do we predict the products? Well, this one doesn't have as many steps as single replacement, but there are a few steps. First step is we're going to underline our positives. And yes, eventually you won't have to do this, but for right now, I would like you to start by underlining the positive elements. So we're going to go through and underline our positive elements. And then we're going to move positive elements to the other compound. So basically your positives are just going to switch partners. The key here is that you do need to crisscross. So our third step is we're going to crisscross and find new compounds, crisscross and reduce, so we can find the correct formulas of our compounds. And as it has been for quite a while, our last step is going to be to balance. So our first step, we're going to underline the positive elements. Then we're going to move our positive elements to the other compounds, just making them switch partners, if you will. We're going to crisscross and reduce, and our last step is going to be to balance. So let's go ahead and take a look at that keeping those steps in mind, and we will work through this first one where we have NaOH plus H2So4. So Na is our positive element there, H is our positive element there. These guys are just going to switch places. So Na is now going to be hanging out with SO4. We know Na is plus 1, SO4 is minus 2, plus we know H, which is plus 1, is going to be hanging out with OH, which is minus 1. And so I guess I probably should have changed to red there, but we're going to jump right down to number 3 where we crisscross and reduce. We have Na, which is plus 1, and SO4, which is minus 2. So to crisscross, we're going to put a 2 there, and then we just have one SO4, and our formula for HOH is going to stay the same. So we can erase our charges here. And now our last step is to go back and balance. So going back and balancing, we check it out. We have 1 Na, 2 Nas. Okay, so I need 2 Nas. Now I have 2 OHs. To get 2 OHs on this side, I put a 2 out front. That gives me 2 H's, 2 OHs. So check in, 2 H's. 2 H's, 1 SO4, 1 SO4. We have our balanced chemical equation. All right, let's move on to another example. Our next example, this one we have PbNO3 and it's reacting with Ki. So our first step is going to be to underline our positives. Remember, our positives are going to be switching partners. So on this side, Pb is now going to be hanging with I. Pb is 1 or plus 2, I is minus 1. Plus K is going to be hanging with NO3. K is plus 1, NO3 is minus 1. Alright, our next step is to crisscross and reduce. So we've got Pb, which is plus 2, and I, which is minus 1. So we put a 2 behind the I when we crisscross and reduce. K and NO3 are okay, so that's our formula for that. So let's go ahead and do some erasing of some numbers here of our charges so we're not confused. And now we get to go back and balance. This is our last step. 1 Pb, 1 Pb. 2 NO3s, 1 NO3 on this side. So if I put a 2 out front, that gives me 2 Ks, 2 NO3s. So 2 Ks. Now I have 2 Ks, now I have 2 Is. We are done. Just finish it out with 1s there. Alright, our last example takes us from words to formulas. So we've got solutions of calcium chlorate and lithium sulfate are mixed. So we have to first write the correct formulas for calcium chlorate and lithium sulfate. So calcium chlorate, calcium is Ca, it's plus 2. Chlorate is ClO3 and it's minus 1. So our correct formula there would be CaClO3 parentheses 2. And we're going to add lithium sulfate. Lithium is Li, it's plus 1. Sulfate is SO4 and it's minus 2. We got our arrow going. Alright, we got to get our correct formula here. Crisscross, we get Li2SO4. So let's erase those charges here. And it says, our first step says to underline the positive. So Li is a positive and Ca is a positive. Our next step says to have our positive switch places. So Li and Ca are going to switch places. Ca is now going to be hanging with SO4. And Li is going to be hanging with ClO3. Our third step says to crisscross and reduce. So if we look, if we crisscross here, we get 2 and then parentheses 2, right? But to reduce, we've got to reduce out those 2, so we lose that 2, because one of each balances it out. If we look at lithium chlorate, that formula is correct as well. So erase our charges here. And our last step is to go back and balance. So if we look, 1 Ca, 1 Ca. 2 ClO3s, and I only have 1 on this side. To get to 2 ClO3s, I put a 2 out front. Now I have 2 Lis, 2 Lis. All right, my Lis are balanced. SO4, SO4, we're balanced. So if I just put 1s in the other spots, we are done. All right, that was our final last bit of notes.